Hello dear children. In this video we will discuss about chapter number 5, known as powers and roots. So we will just discuss about the powers first, okay? Then we will come to this part, roots, later on, okay? So let me just tell you in brief. This power or exponent or index, whatever you say, it is the same thing. Okay, so don't get confused when I have when I use the term. You can see out here that I have used the term indices. Okay, so indices, it means powers or exponents. It is just the plural form. Okay, so indices is the plural form of index, and index means the power. Power means exponent. Okay, now let me just take you to this number. Okay, 16. Let us just assume it to be 16. Okay, it can be any number, like let us say 4, or it can be 25. Okay, so 25. So when we prime factorize this 25, you can see that 5 will multiply with itself. That is 5. Okay, 5 into 5, then we get 25. Okay, so this number, okay, this 5 is repeating itself. I mean, this 5 is repeating for 2 times, isn't it? So this 2 is known as the power or index or exponent, and this number, that is 5, is known as the base. Let me just take you to this picture. As you can see out here in this particular picture, we just, okay, yeah, you can see out here in this number, I mean in this picture, 9. Okay, if we prime factorize this 9, we get 3 into 3. So we can see that 3 is repeating itself for 2 times, isn't it? So this 2 times is actually your power. Okay, it can be written like this, and this number 3 is known as the base. Okay, so this repetition of the number, okay, how many times the number is getting repeated itself, okay, and is multiplied with itself, is known as an exponent or power or index. Okay, and the number is your base. Okay, so this similarly 16. Okay, you can see that it is being repeated for 4 times. I mean, the 2 is repeating, this number 2 is repeating itself for 4 times. So this 2 is your base, and 4 is the power or exponent or index, whatever you want to write. And for 4, we can write like this. Okay, uh, this 16 can also be written as this. 4 into 4, 16. Okay, 4 fours are 16, so 4 to the power 2. Okay, that is the 4 square. Okay, so we call uh, 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 it as square. Okay, when the power is 2, we call it as square. Okay, and when the power is 3, we call it as cube. Okay, let me just show you one number, that is 8. So this 2 is repeated itself for 3 times. So when the situation is like this, when the power is 3, we call it as 2 cube. Okay, and when the power is 2, we call it as 2 square. Okay, but when the power is 4, 5, 6, 7, 8, 9, 10, okay, we call it as 2 to the power 4. Okay, when the power is 5, we call it as 2 to the power 5, or 2 to the power 6. Okay, but when the power is 2, we call it as square, and when the power is 3, we call it as cube. Okay, so the definition of exponent can be uh, expressed such a way that an exponent is a number that states how many times the base number is to be used in multiplication. The exponent number appears on top right of the base number as a small number. So this is your definition. Okay. But see, the definition is quite complicated out here, isn't it? So you can make your own definition according to your own understanding. Okay, it's not compulsory that you have to write the same definition. Okay, please make sure that you first understand the concept and try to make your own definition. Okay, so it basically is referring, okay, this exponent. What do you mean by exponent? By exponent, we are referring to the power or index. Okay, so exponent is such a number that states how many times, okay, this 2 or 3 or 4. Okay, so this is your exponent, power or index. So by exponent or index or power, we refer to such number, okay, to such number which states that how many times the base number is to be multiplied with itself or to be repeated itself in case of multiplication. Okay, and this number, it appears on the top right side of the base number, okay, as a small number like this. Okay, I hope you know the concept of exponent now. Okay, if there is any kind of confusion or maybe I couldn't explain you such a way, please let me know. Okay, now I believe we can continue with the exercise, but before we move on to the exercise, we must first understand the laws of indices. Okay, what are the laws of indices? Now this laws are mentioned in page number 75 and 76. Okay, there are 7 laws. I have tried my best to explain you in a very simple manner. Okay, so I hope you will understand properly. Okay, law number 1. Now, in the powers of the numbers, okay, whatever the numbers, that is the base numbers. Okay, whenever we are referring to the numbers, we are actually referring to the base number. Okay, this is your base number, this is x. Okay, so when the powers of numbers with the same base should be added if the numbers are to be multiplied together. Very simple. In your book it's written like this x is a natural number, whereas a and b are integers. Okay, I'm not going into it. Okay, I'm just telling you in a very simple manner that when there are the numbers, okay, whose bases are same. Okay, as we can see out here in this particular example, that these two numbers, okay, are to be multiplied with different powers. Okay, so this a is a different power and this b is a different power. Okay, so let me just uh, zoom it so that you can see properly. Anyway, so now see this, these two numbers, I mean the base numbers are same but the powers are different. Okay, so when the base numbers are same and are to be multiplied with each other, okay, but with different powers, then these powers are to be added together. Very simple, and the base number will remain as it is. Okay, and remember that these a and b are integers. Okay, it can be both positive and negative. Okay, please make sure that these exponents, it can be positive as well as negative. Okay, now let us move on to law number 2. Now the law number 2 is just the opposite of law number 1. Now in law 1, these numbers were being multiplied. But in law number 2, it's to be now divided. Now when there is this sign of division, it should be noted that these powers must be subtracted. Okay, so that is a minus b. Okay, and now law number 3. Law number 3 is very simple. As we know that the powers, they are integers. Okay, they can be both positive and negative. But when there is a negative power, it means it is the reciprocal of that particular number. When there is a negative power, then we call it, the number will be just the reciprocal of it. Okay. Now, law number 4. Law number 4, as it is mentioned in the book, because I couldn't find a very simple term to explain. So x is a rational number. Okay, I hope you know what is rational number. Okay, now integers you already know. So when the situation is like this, okay, there is a base number out here, okay, and this base number, it has a power, and there is the bracket out here, okay, and after the bracket there is again a power. So in such case, what you will do is that you will just multiply these powers, a into b. When you open the bracket, the powers will it will be multiplied. Okay, a into b. For example, let me just show you out here. Uh, let me just show you. Uh, sorry, made a mistake. Okay, let us suppose, okay, this power to be 3, and okay, and this is your let us say 5, okay, and this is your 2, okay. Then what will happen is we will write the base number as it is, okay, but this 2 and 3, it will be multiplied, and we will write it as 2 3s are 6. Okay. Law number 5. If there is any number with 0 as power, then it means it is equals to 1. Let me just give you one more example. Uh, okay, so let us assume it to be 100. Okay, let us write 100 to the power 0. It means that it is equals to 1. So if there is any number with 0 as power, it always equals to 1. Okay, it can be 200 to the power 0, again 1, 300 to the power 0, again 1, 5 to the power 0 equals to 1. So if there is any number with 0 as power, it always equals to 1. Okay. Now let us move on to law number 6. Okay, so if a number has 1 as power, then it equals the number itself. 7 to the power 1 equals to 7, which means the number is being repeated only one time. Okay, let me just give you more example out here. Okay, let us write 10. So 10 to the power 1 equals 10. Let me just write one more example. Let us write 25. Okay, so 25 to the power 1 equals 25. Okay, so if there is any number which has 1 as power, then it means that it equals to the number itself. Okay, that is the base number. Okay, so this 25, this 10 and 7, they are the bases. Okay, and this 1 is the power. Okay, so when 1 is the power of any number, then it equals to the number itself. Okay, now let me just show you law number 7. Okay, so if x and y are rational numbers and a is an integer, then let me just give you a very simple example, okay, with a number. Okay, just understand this situation. I will not explain this, but I will show you with the example. Okay, mm, let us say uh, okay, so mm, okay, let me just show you. Uh, okay, let us just write, let us say 6. Okay, and here we can write 3. Okay, and let us assume that the powers are same. Okay, the base numbers, it can be different. Okay, the base numbers, it can be different, but the power has to be same. Let us write 2. Okay, 2. So when we simplify this, what happens is this power will go outside the bracket, and 6 threes are 18. Okay, so this is what it is happening out here. Okay, and in such this case, okay, when we have a fraction, you will do the same thing. Let us say we have a number mm, just right. Okay, okay, again 6, same example, 3. Okay, the base numbers will be different, but power is same. Okay, so in this case what happens is this 2, it will be for both, because this power 2 is common in both these numbers. Okay, so it will be 2 and 6 divided by 3. Okay, and finally we can simplify it. Okay, so this is your law number 7. Okay, see dear children, you must understand the concept. Okay, it's not necessary to learn each and every single thing. Yeah, but you must remember, okay, that there are 7 laws, and each law states some kind of property. So you should know the property. Okay, if you understand the property, you will understand the concept. And once you understand the concept, it will be very easy for you to apply the same when you solve the questions. Okay, so in the next video, we will have a look at the solution of exercise 5.1.